All right, here is the Blue Rainbow Review, and the Blue Rainbow Review covers the section of 10.7, which was dealing with inverses. So one major thing you need to know about inverses is it switches the x's and the y's. So when we're looking at a table of values, that's literally all you need to do is what was once in our y column is now going to go in our x column. So -3, -2, -1, and 1. And what was in our x column before is now in our y column, -2, -1, 0, and 1. You can do the same thing for the second table. Number 2 is graphing the function and its inverse. Multiple ways you can do this. My suggestion would be the fastest way to graph this would be to use slope and y-intercept. So our y-intercept here would be -4, which is our y-intercept. So I would plot a point at -4. And then I'm going to use slope, which is 3. 3 over 1. So I'm going to go up 1, 2, 3, and over 1. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. And that gives me my original function. Now, the other option you could do, if you would like to, is you could make a table of values. All right, so you could create a table of values by plugging in values for x. Or you could even take the points that you just plotted and make them into a table, but our values would be -4, -1, 2, and 5, I believe. So this is for our original function f of x. Now, if I want to graph the inverse function, f to the -1 of x, remember that's just notation. If I have a table of values, I can just flip those columns around. So -4, -1, 2, and 5, and then 0, 1, 2, 3, and that gives me some new points to plot. But you could also do this visually if you would like to. -1, 1, 2, 2. Now remember that 2, 2, it doesn't actually change because you're flipping over that line y equals x. So when we switch those 2 and 2, it stays 2 and 2. Now they're asking us to write the equation for that function, which is a little bit difficult to do, trying to figure out the y-intercept here. Slope is pretty easy to figure out, up 1 over 3, but that y-intercept I'm not sure about. So another way we can do that is by looking at the table. So remember, if we're doing y equals mx plus b, that m, or the slope, is my rise over my run, which is what's happening to my y over what's happening to my x. So my y's are going up by 1, and my x's are going up by 3. So my slope is 1/3. My y-intercept I find when my x value is 0. Well, now this again is a little bit trickier because my x value, do a little side table over here. I have -1. This would be 0, 1, 2. So the -1 value was 1 and the 2 value was 2. So it's like, how do I find this step? Well, going up, I was going up by 3 on the x, and on the y's, I was going up by 1. So I actually need to go up 1/3 in order to get that step. That's a little bit more complicated of a problem than I think we're used to, but you can problem solve through it. You can also do this algebraically if you need to, which we'll show in the next example. All right, then the next example is finding the inverse of the functions algebraically. I want to look at two of them in particular. The first one is letter B I want to look at. So again, the first step in finding the inverse algebraically is I'm going to write this as y equals, because who wants to write g of x over and over again? But then I'm just going to switch my x's and my y's. So I still have the 1/5 and I still have the 4. Now I just need to solve this for y, get y by itself. I'm going to subtract 4 from both sides. I'm going to run out of space, so I'm going to move it over here. So if x minus 4 equals 1/5 y. The reason I wanted to do this problem is because trying to figure out what to do with this 1/5 is a little bit more complicated. One option is you could divide everything by 1/5, but that kind of gives you a weird goofy answer on the left-hand side. So my preferred method is to, instead of doing 1 divided by 5, is to multiply by the reciprocal, 5 over 1. What that does is it cancels the 1/5, so we're just left with y. Now, what I have to be careful of on this left-hand side is the fact that I am multiplying 5 over 1 with the whole left side, x minus 4. So really, I have to do 5 times x and 5 times negative 4, so that gives me 5x minus 20. Now again, rewriting this using proper notation would be the inverse of g, or g to the negative 1, equals 5x minus 20. Look down here at letter C. Again, write it as y equals 6x squared, but then I'm going to switch the x's and the y. So I have y equals, I just rewrote it, x equals 6y squared. I want to get y by itself, so I'm going to start by dividing by 6 on both sides. So I have x divided by 6 equals y squared. Taking the square root of both sides undoes the squared. Again, running out of space, so now I have the square root of x divided by 6 equals y. Writing that in proper notation, I would write it the other way. So h inverse of x equals the square root of x divided by 6. Now remember, you can write that in multiple different ways. You could write the square root of x over the square root of 6. You could write it as the square root of 1/6 x. All of that would be the same, but everything is underneath a square root. Last problem to talk about here is problem number 4, and the reason why I want to mention this one is because it's a little different than finding the inverses like we did above. When you have a problem that involves a formula of some way, shape, or form, right? We do not want to switch the variables because we don't want to change what their meaning is. If I have a v, it makes sense to leave it as volume, or leave the idea as volume, not to change it as the radius or change it into height. I want to leave the v meaning volume, I want to leave the r meaning radius, and I want to leave the h meaning height. So when you have a formula, do not switch the variables. They want us to, let's see, let h equal 5. What is the inverse of the function for the radius? So they want us to basically plug this in and then solve for, r. So I wanted to have r equals versus v equals. So we'll start by writing v equals pi times the radius squared times, instead of writing h, I am going to put that 5 there. I'm going to rewrite this slightly because one fun fact is that pi and 5 are both our numbers. So it's a little bit easier to think of this as 5 pi r squared instead of having them kind of rearranged. Now, all of this is multiplying. So in order to get rid of the 5 pi, I need to divide by 5 pi on both sides. All right, just like we divided by 6 in that last problem. So I'm left with v divided by 5 pi equals r squared. And then again, just like in the last problem, in order to get rid of that squared for my r, I need to take the square root. So I now have, I'm going to flip the order a little bit because it's written as r equals the square root of v divided by 5 pi. And just like in the last problem, there are multiple ways you could write your answer. You could write it as the square root of v divided by the square root of 5 pi. You could write it as the square root of 1 over 5 pi times v. I personally write it like this because I'm lazy and like to do the least amount of work possible. So there you go. Hope that helped.